So please try to go with him, and any issue,
Yeah.
let us know.
Yeah, so here first at all we are going to develop task 1. Here we see this is a very simple circuit. Build a simple circuit where a simple load is connected with PMFC stack and observe the voltage, current and power characteristics. So for doing that, use 45 volt 6 kilowatt built-in fuel cell stack, a series RLC branch for loads, and a scope for results observations. So we are trying to do the first ones. It is for the very beginner. We first click MATLAB. So this interface will open. So this is the programming interface. From here we can see. So it is also vary from version to version. So this is 2023 A version. So if we need to go first Simulink here. So this is the Simulink. So from this Simulink we need to take a blank model. So this is the blank model. So on this interface, if you clicking double in your right cursor of your mouse, then this kind of pop-up will show. Just right here, fuel cell, as I said, fuel cell stack. So we can take a fuel cell stack like this. So after clicking double on this block, so we are selecting like simplified model, and this is 6 kilowatt. For example, this one we are going to take. So click it OK. So from here we can connect any load across the positive and negative. So again the same things, if we need any components anytime, just double click your right cursor and then right here like series RLC branch. For example, we are taking this one, series RLC branch. So if you click here, then we can do some rotations like orientations or format. So here we can see rotations. So if we double click, if we want to change the parameters of this, just double click. Similarly, like fuel cell, double click. So if we want to take only resistance, we can take. So it's, and this value, like if we want to see, for example, here, so the current is this much and voltage is this one. So according to Ohm's law, we can put any value, but we are putting like this, 45 over 1 on this mass. For example, this is the resistance value. So click it. Then if we go close to the terminal like positive negative, then it will automatic comes where you just drag and connect to your other points. You see, just drag it to the other terminal. So it is the very simple circuits. So now we have to measure the voltage, currents and power of this one. So how can we do? Just double click here, same way, voltage measurements. We just take voltage measurements. It is actually voltmeter. Physically, the things we do in our laboratory lab, this is voltmeter. So we just remove one and make it plus here. Oh, sorry. So we have to connect voltmeter in parallel because we are measuring voltage. So plus here, plus here, and it shows us the signal value, the what would be the voltage across these two terminal. So we can choose this one. Then similarly we need to measure current. So we can write the same things, current measurement. So plus this is minus. So this one give us the current passing through this branch. So now we have to see the value in oscilloscope. So we can write here is scope. So then it is like oscilloscope, the things we are doing in the lab. So double click here, so we can change its property, many things. The way we are want to observe the results, we can do. For example, we are taking here two scope. So layout should be like this way, vertically. So you see there are two scope. If we want to see current in the bottom scope, just connect it, and voltage to the up scope we can see. So here if we click now run, then you see there is a error. So that means this circuit is not complete because we are taking fuel cell from, if we again go like fuel cell. So here the library name is specialized power system or sources. So if we use any components from this library, specialized power systems or sources, we need another component. This is called power GUI. Power GUI, here we can see. So we need this one. So it has three mode of operations. So these are the detailed things. So here we can see four mode of operations: continuous, discrete, phasor, and discrete phasor. So we keep for this one continuous. Now if we are going to build this model, so this model is now, there is no error. If we see, so you see it's almost 45 volts in the voltage, measured voltage, this one, and the current is 133 like this. If we want to make it bigger, yeah, it's the same value. That means the value we are inputting here 133.3. So this way we can use this fuel cell as one of the DC voltage source. This is just simply one kind of DC voltage source, but it operates, it needs hydrogen as a fuel. That means it is a kind of machine which takes a chemical energy, that means hydrogen, as a input and provide electrical energy as a output. So this is a very simple circuits. So in this way we can, step by step can develop more complex circuits. So we can move to the next. So until now, anyone has any question?
Any question or problem? Or all good? So one of them asking, like, you have considered continuous, right?
Yeah.
But there is like, so when you have got like phasor measurement, so that means like RMS,
Correct.
right?
Yeah,
It's
yeah.
like only
There is-
electromechanical. But if you consider like continuous and discrete, you are also considering some other dynamics as well. Is that everything, or you want to add anything, Biplab?
Sir, for continuous and discrete, actually, if you want to incorporate in your design any power electronics, that means is there any nonlinear switching element?
Yes. So when you have got like
So
nonlinear switch power electronics, then you have to go for discrete model, right?
yeah, discrete. And if you know have only mathematical model, that means you don't have any components like this IGBT, then any diode, then any transistor, then we don't need, then you can go only phasor mode. For phasor mode is little bit quicker.
Yes.
Actually, this provides you RMS analysis.
Yeah.
So if, for example, if we change it from continuous to discrete, for this case actually, and this is the sample times, that means it's based on the iterations as solutions. So from one time step to another time step, it takes your defined value. For example, if we are taking 50 milliseconds time step, so the total simulation time you see this must 10 seconds. So how many iterations it it will have now? So it just this much divided by this value, like it is a specific iterations to cover this time. It actually solve this model for a specific iterations, not continuous.
Yeah.
So
Yeah.
one more question. Library, if we build this fuel stack model
Yes.
using equations, then what we need to use
Yeah, yeah,
there?
yeah. You can do it using your own.
No,
Yeah, yeah. So for that, I can show you. So for example, if you have, you can do these things two way. For example, if you double click here, then you can just choose your user defined. So you need then manufacturer value, like what would be the uh, open circuit voltage. So you need this manufacturer value to complete your user defined. If you have any handwriting, hand calculating value, you can use this one. Or if you have any manufacturing value, that means you are collecting from literature, or
So I think
you have
Biplav,
bought from your.
Biplav, I mean, her question is like, I understand that if you use like user defined, but still you don't need to write equation. They're gonna use the inbuilt equation by using the input parameter that you're gonna make as input. Uh,
Yep.
but other way also, I mean, what she is asking that she's not gonna use this model. So
Yeah.
if she wants to develop, so I think two-way, I think you can done like using m file like one way that you just model that equation that we I mean he discussed like in detail in that paper. So it's a simple equation. You write MATLAB code using defining some function or for loop. The one way you can do it. Other way also you can do it using Simulink. There is a like a user defined function.
When we use that as a mathematical equation and model it,
Yeah.
then in that GUI,
You mean the in
Which
Simulink or
one?
M file?
M file.
M
M
file,
file, M file and
M file you
Simulink.
don't need. M file
No
you
sir,
don't need.
M file and Simulink both are linked.
Yeah, you can link both as well, but
That-
you can also do also separately. Like only M file also is possible.
Okay, okay.
Only M file. You are not using any block. You are just using the MATLAB coding.
Yeah, but when I use both, then what
You can
has
use
to
both.
we can use. Then that time, what should be that power GUI? What we should use, whether it is continuous or phasor.
Power
When-
GUI actually you need if you want any component from specialized power electronics sources or
Yes.
components library. Any components from this library, if you are going to use, then you need Power GUI only.
But if you just use like normal user defined block, you don't need that, because in that case
Yeah, yeah, you
you are
don't
not
need,
using their existing component.
because series RLC branch, these all things you can find only within specialized power sources or components library. So if any components, even a tiny components like voltage measurement, current measurement, if you use any simple components, then you definitely need to use Power GUI.
Yeah, so we can't see your like skin now. So
Yep. It's not showing.
Mask, and then you can just do the simulation showing the result. Can you just go a little bit under the mask?
Under
the mask, like different, showing different subsystem.
yeah. If this is the block, how this block can be built. So you just right click, then go mask, look under mask. So if you go, it is basically based on the mathematics. So the things, all input are given here. You see the air pressures, all things. So if we go, this is the model. So if we use continuous detail, then it's automatic, select this block. There are lot of blocks they have created. It's based on the power GUI option, selection option. So if we are using continuous detail, then it should focus only this block. If we are choosing continuous simplified, then it should only use this block. So like this way, discrete detail this way, and discrete simplified. There are, for example, we are solving this model using discrete. So discrete, if we click here, and this is detail. So based on our input value here, so they are using this one, discrete detail, that means this one. So if you click this one, so you see these all are the input. That means if we go back these equations, there are a lot of input variable, and based on this output variable, so this is actually the voltage, utilization factor calculator, partial pressures calculator. So all things are given inside this.
So at the end,
So
you just need to know the equation, and how you are solving. That depends on your preference, either using the block or using simple coding and so on. Yes, continue.
So just a moment, I have the things students are asking. I have the same things. Just 1 second, I have to open it. Yep. Here we can see. Can you see this model?
Yes.
Here you see, this is the model. That means this is the electrolyzer. It is connected. This is not fuel cell, but the principle is very similar. When input is hydrogen, then it is fuel cell. Then when input is electricity and output is hydrogen, then it is electrolyzer. So you think it is a kind of fuel cell. So here we can see, if we go inside this, so the professor said this is the MATLAB functions block. Here we can see we defined all things. This is the ohmic drops. This is the length of the membrane thickness. So these all are given. This is the area of the activation membrane. So this is the number of series connected cell. This is the number of parallel connected cell to make the stack. This is the ideal gas constant. So this way we are inputting here all values. So from there, this is the reference temperature and pressures. All things are operating parameters. It is my developed model. So here we can see how we can calculate internal resistance.
Can you see like that? You are just writing the equation in MATLAB. Solving is very
MATLAB code.
Very simple. You just giving the input, and whatever equation you are just writing.
Okay, here for example, this is the gift-free equations.
Their model. It's very simple to do it by this way as well. Yes, yeah, continue.
So here we can see this is the gift-free equations. The same equations I represent you in my presentations. But it definitely needs time. Actually, you can't do it one day or 2 day, so it definitely needs time. For example, if we are picking from any equations, yeah, so this is, you see this part, delta Z over ZF. So this reversible equations is developed here. Delta Z reversible 2F. Z means the number of electron. For oxygen, for hydrogen, there is H2. The compound is H2. So number of hydrogen is 2. So this is that value. So this is the equations for over voltage potentials drop. Here we can see this is the equations for over voltage potential drop. If we go these equations again, so these are the simple things actually.
Yeah, I mean,
So this is the
it
equations.
will take some time, but it's not that difficult to do it.
Yeah, just I have write these equations here. So in such way, so this is the hydrogen productions, that means milliliter per minute. That things I already showed you. So this is the power based on the hydrogen supplied. This is the power. So in such way you can easily develop. So if I am going back again, you see this is the, that means if we want to develop based on this mathematics, so this is that functions. There is, you can easily then connect other components, like this is a this is a boost converter. You see this is a boost converter connecting between the source and load. For example, in this our current model here, where is that model? Here, so here we can see there is no, so this is the load and this is the source. Here we are not using any converter like DC DC buck boost, any kind of power electronic interface we are not using here. So that is why, but if we want, you can use, it's like this way. Here it is a boost converter, so this way, and this is the another model. So here we can see how we can, this is the hydrogen tank model. So I'm just showing you the same way using mathematical functions. That means mathematical scripting, we are developing the tank pressures. So any model you can either use block, or you can either use scripting inside this MATLAB functions block. This is the MATLAB functions block.
So that's
So
the one I was
that's the
talking about, that you
thing.
can use any MATLAB function to write down your own equation coding here. So yeah.
And it's definitely reduce the number of block as well. You see many things we can do inside a single block.
Yeah.
So any questions until now?
No, I think all good. I mean, whatever you want to show, now. So just show some result, how they can produce some result and show the performance.
Okay, for this one, the same circuits actually, here we see there is a measurement terminal. So if we want to see the measured parameters, different parameters of this fuel cell stack, like what is the utilizations. So if you click here, at the bottom side there is a measure, no, it's built in. So it means there is a, so if you click here, these things you can actually, by default you can observe this kind of results, this kind of parameters. So voltage, current, stack efficiency. So this way you can observe this one. So I am now using this, using this bus selector, I am only observing these three parameters: utilizations, stack consumptions, that means liter per minute, and stack efficiency. So if we run this model, Yeah. So here we see utilizations. These are two type of utilizations: oxygen utilizations and hydrogen utilizations. So if you put some legend, then we can have. So oxygen utilizations is the yellow color. That means this is 60% and 100% hydrogen utilizations. So the fuel consumptions liter per minute, that means for providing this output, that means if we want to increase load here, so based on this the current also increases. So if the current increases, then the supply of both air flow rate and fuel flow rate both need to be increased. So this kind of things, actually this way you can see the results. And the stack efficiency is how much, here we can see. So the stack, so stack is operated in between 66% to 68% efficiency. So this one, so before we took here voltage, for example, if we have to remove here, so this is double click voltage measurement block, the same things we have just placed here. So this line, actually this line here we see, this is the first channel. In this oscilloscope we have 3 channel. The first channel, there are 2 input, this one and this one. So this one measuring our, you see from here, so the same line, this one measuring our voltage, the lower one, and this one measuring our fuel cell stack voltage. So here we can see this is the stack voltage and this is the voltage across the load. So if we go the first channel one only, here we can see this is the first channel one. Channel 1. So if we put here legend, so you see the voltage between the voltage across the load and the voltage of stack same, because it is 45 volts and this load is connected parallel with this terminal. So that is why the same voltage we can observe from here. So if we click here, then this one hide, this one highlighted, because the same value, that is why it's overlap one other. If there are different value, then we can see difference. For example, here if we connect another resistor in series, then there are 2 branches, RL, 2 resistive branch. So this voltage measurement, this voltmeter measures voltage only this one, but this one and the voltage across the fuel cell is the combinations of this one plus this one. So you can see now the difference. For example, you see now the voltage across this one, only this one is reduced, and this is, since the branch resistance this one and this one equal, that is why the voltage reduced to half, 45 to half, I think. Here we see this is the almost half of this. So this way actually we can see the results. So similarly, like here we are inserting here this component, this is ammeter or current measurement. So we place it in series. So you see, so this one actually goes here. So this is the current supplying by this electrolyte fuel cell, and this one the current we are measuring from here. That means the second channel of this scope measured current. So here we can see this is the second. So both current, this is a series circuit. So this is why both parameter are same. You see, same. This one actually, the third channel here measured the power. So this is the total supply power by this fuel cell, and another one the power consumed only by this resistor using a product block. That means voltage multiplied by current give us DC power. So one is for power consumed by this electrolyzer, this load, DC load, and another one is supplied by the fuel cell. That means this one. So if we see the third channel, here we can see. So this is the total power supplied by the fuel cell, and this is the power consumed by the load, only the second load. So now this is the basics. So have a look on it, and can you do some little modifications of this circuit based on these questions, task 2. Yep, just see here.
So we have got like another 10 minutes. I don't know. I mean, if you want to try now, otherwise maybe you have to try later. So, Biplav,
Yes, sir.
you just give like hints how to do it, and then you send me the task. I will give it to them. But just give some hints how they can do it, and then you can finish it.
Yeah. So here we see the same things. Actually, here from here we are selecting this one, 6 kilowatt 45 volt DC. So based on this, the power supplied by this fuel cell, 6 definitely equal to 6 kilowatt, and the voltage across this terminal, positive and negative terminal of this fuel cell, it should be 45 volts. But from here, if we see the voltage supplied by the stack, this is the yellow one, so this is more than 45 volts, you see. So my question is why? Because the nominal operating voltage of this fuel cell is 45 volt, but you see the voltage higher than the nominal voltage, 45. And also power, the maximum power supplied by this fuel cell is 1 kilowatt, not 6 kilowatt. So that is why if we go back again to this fuel cell model, for example, VI characteristics, so we can operate this fuel cell any region of this characteristics line, any region. But this one only our nominal operating point. So here the voltage is 45 and current is 133.3. But if we see our results, so this is how much. So if we make it little bit zoom, so our fuel cell operate at like 57 volts. So if we go back again this plot, so 57 means like, I think, so we can assume this point. So like this one, 57, 56, 57. So for example, this point, you see the current is how much? 20.25. So if you see again this, so you see our current like this one, total currents. So it is like this much, total current 17. So that means from this point we can see, so our fuel cell actually operate this point, not this point, because this is open loop. We are connecting load across the fuel cell as a open loop manner. There is no closed loop control. That is why, so at that point, if you divide these two values, the resistance definitely is very less resistance. So according to the nature of, from the relative resistivity law, we can know current has tendency to pass low resistive path. So if this fuel cell operate at this point, so why need to operate that point? No need. So easily they are selecting this point or any other random points at this point or this point. So it's not operate. So for operating this one, we need another device. This is controlled device that can help to operate this fuel cell at the nominal point, because if we have reference current that can bound the circuit to operate at that point. For example, if we develop a controller that can bound the circuit to operate the current at 133.3 ampere, if the current is this much, then definitely voltage come back to 45 volts. So that is why we need some reference value, we need to provide some measured value. So where we can insert this value, we can input it in any power electronic device. That is why in my questions I put here, we can do it using a DC-DC converter, either it is boost or buck. From here we can put the reference current or voltage to operate the fuel cell stack. So in such way we can operate fuel cell at its nominal operating point or any other operating points. Can you guys try it? If you can try first, if is it possible, otherwise I can show you. Just thinking, because I think you have massive knowledge how to develop DC-DC converter, buck, boost, or using separate IGBT or separate transistor, or using built-in. There is in MATLAB there are a lot different type of built-in converter, using chopper, using 2 level, 3 level, different. So just try to think it. Task 3. So as here we can show you here at the very first time, so we can use any user defined functions from here. We can input any input. So for example, in this design I input fuel flow rate. So here, so how we can use this type of user defined signal in our fuel cell stack. One example is that one, simple circuit through DC-DC converter to operate the using user defined signal, for example flow rate or oxygen rate or user defined utilization factor. So this is the another thing. So for that one I am explaining this one. So this is the last task. So you see this is the same circuit here. In between the fuel cell and load, I am inputting here one DC-DC converter. That means that this is the second one. So here we can see this is the DC-DC converter. So this is the measured voltage. So we input this measured voltage, for example 45 volts. So this is our reference voltage. For example, this is our reference voltage, for example 100. So this control, this is PI based control strategy. This controller actually try to adjust the measure voltage, whatever it is, make it equal to 100 voltage. So if we have known operating point voltage, then we can easily operate this stack at a specific voltage. So this is the second one. And third one, here we can see we are using here fuel flow rate. So for that we are taking input from here. We are taking input current, and then if we go inside this one, this block, there is a functions block. They are actually using a mathematical calculations. In this calculations only the current is the input and other all parameters are the constant. So if we go back, only input is current and other all are the constant. From where we get these equations, I showed you at the very beginning. Go to help, they are showing you the equations how we can. Yep, you see, yeah, these equations actually is start from 60,000 from here, 60,000. So if we go back here, so in this design, so you see it also start from 60,000 because it is based on the same equation, just we have write here these equations. So then you can easily, in such way you can easily input your user defined signal based on your current profile. That means if it is highly highly static, highly fluctuating in nature, then you can, based on that, you can develop these equations and readjust the fuel flow rate to ensure that your fuel cell stack operate your defined utilization factor like 80%, 90%, whatever you want to operate this fuel cell. These things actually ensure you that your fuel cell operate at that particular value. So that's all, sir, from my side.
So we'll have. Do you?
Biplav,
Yes.
thanks for your time. So you can just email me those tasks. I will give them, and they're gonna try their home later because we don't have enough time to do it now. Again, many thanks for your time. So you can probably disconnect, but email me those things that you have done. I'll give them that MATLAB model and the things that you said. They're gonna practice by themselves.
Okay. Thank you so
Just,
much.
just email me everything, and then I'm gonna give them. Okay. Thank you.
Yeah, I'm now after leaving. I will send you email. Yep. Thank you so much. Have a good